Welcome to the Health Headliner podcast by Tudu Digital. Our content is informational only and not medical advice. Please consult your provider. Now, let's dive into today's headlines.
All right, so let's unpack this. For many of us, the thought of cognitive decline, particularly dementia, it's a big concern as we age.
It is, yeah, natural worry.
But then for people managing type 2 diabetes, that worry, it's even more pronounced. We're talking about a risk maybe 70% higher than the general population.
That is a staggering number. It really highlights how connected everything in the body is.
Exactly. So what if there was maybe a new frontier? Something promising for protecting brain health specifically for people with type 2 diabetes, maybe something already in their treatment plan.
And what's really fascinating here, I think, is the potential for a genuine, game changer, not just for blood sugar, but for keeping our minds sharp, preserving that cognitive function.
That's such a key point. Welcome, everyone, to the Deep Dive.
It's great to be diving in.
Today, our mission is to get into some really captivating new research that could profoundly change how we think about managing type 2 diabetes. We're looking beyond just glucose levels, focusing squarely on long-term brain health. Our sources. Well, there's a recent health news article that caught our eye, but more importantly, we're looking at a large scientific paper. It was published in the journal BMJ Open Diabetes Research and Care.
A very reputable source.
Definitely. And this deep dive, it's your shortcut to understanding these, cutting-edge findings, what they might mean for future care, and, what questions are still out there for researchers.
And it's just such an important area. The burden, societal, family, economic, of diabetes-related dementia it's immense. Preventing it is, understandably, a really urgent public health goal.
Okay, so let's get into the study itself. The core problem they were tackling was this. You've got these two widely used type 2 diabetes drugs, glucagon-like peptide-1 receptor agonists and metformin. Both have shown some promise, right, for protecting the brain.
Right, there were hints in previous research.
But there hadn't been a direct kind of real-world comparison of how they stack up against each other, specifically on dementia risk. That was a big gap.
Exactly. A critical void. I mean, if both types of drugs have these neuroprotective qualities, the big question becomes, which one actually works better? Which offers superior protection? That's precisely what they set out to answer.
So how did they do it? It was described as the largest study of its kind.
Here's quite a claim.
It is. It was a retrospective cohort study, which basically means they looked back at existing health records, anonymized, of course.
So looking at past data.
Right. And the data came from this huge global health research network, TriNex. It covered a massive period, 2004 all the way to 2024.
And the scale is, it's really impressive. We're talking 87,229 patients in each group. One taking glucagon-like peptide-1 receptor agonists, the other metformin.
Wow, that's a lot of people. How did they make sure the groups were comparable?
Good question. They used a clever statistical technique called propensity score matching. Think of it as digitally balancing the groups. They matched patients based on age, other health issues, lifestyle factors, you name it.
Okay, so they're trying to compare apples to apples, essentially.
Pretty much, yeah. To isolate the effect of the drug itself, the average age was 58 in both groups. And crucially, they focused only on patients who used either drug as their first treatment, their first-line therapy, for at least 6 months straight.
Got it. So looking at the initial sustained effect.
Exactly.
So the big question then, what did this huge study actually find?
This is where it gets really interesting. Looking at the overall risk of developing any type of dementia, using glucagon-like peptide-1 receptor agonists was linked with a significantly lower risk.
Significantly lower? How much lower?
The numbers are quite stark. The incidence rate was almost 2.5% for the glucagon-like peptide-1 receptor agonist group compared to nearly 5% for the metformin group.
Nearly double the risk with metformin compared to the other group. That's a huge difference.
It really is. Essentially cutting the risk in half for overall dementia. That's a major finding for public health, potentially.
Wow. Did they break it down by dementia type?
They did. And for specific types, the results were, even more compelling in some cases. For Alzheimer's disease, they found a 12% lower risk associated with glucagon-like peptide-1 receptor agonists compared to metformin.
Okay, 12%. That's notable.
And for non-vascular dementia, so dementia is not primarily caused by blood vessel problems in the brain, the reduction was even bigger, a substantial 25% lower risk.
25%, that's very pronounced.
It is.
But there was a nuance, wasn't there? Something about vascular dementia.
That's right. For vascular dementia, they didn't find a significant difference in risk between the two drug groups overall.
Any idea why that might be?
Well, vascular dementia is often driven more by things like strokes or small vessel disease damage to the brain's blood supply. It's a bit of a different mechanism than, say, the protein buildup in Alzheimer's. So maybe these drugs don't target those specific vascular pathways as effectively, or perhaps other risk factors are more dominant for that type.
Okay, that makes sense. Different causes, potentially different responses to medication.
Exactly. Though they did note a small reduction just in women for vascular dementia with the glucagon-like peptide-1 receptor agonists, but not in the overall group. So, still complex.
Interesting. And were there other benefits beyond just dementia risk?
Yes, actually. These positive effects, the lower dementia risk, they were seen across different age groups, but they were strongest in people over 60, in women, and in individuals identified as white ethnicity in the records.
Okay, so some demographic differences there.
And here's something else quite surprising. Really underscores the broader impact. The risk of death from any cause was also significantly lower with glucagon-like peptide-1 receptor agonists. Nearly 5% in that group versus nearly 9% in the metformin group.
Whoa. Lower all-cause mortality, too. That's really significant.
It's a powerful extra benefit, yeah. Goes beyond just the blood sugar and the brain health aspects we've been talking about. Suggests a wider positive effect on overall health.
It almost makes you wonder, as the researchers pointed out, if the brain benefits are maybe even underestimated, because if people live longer...
Paradoxically, yes. Longer survival means more time in which dementia could potentially develop. It's an interesting point they raised.
So let's get into the why. Why this difference? What's happening, mechanistically? Why do glucagon-like peptide-1 receptor agonists seem to offer this better brain protection?
Okay, so the researchers explained that both types of drugs do have these neuroprotective properties. That's the term they use.
Right.
Both seem to help reduce neuroinflammation, cut down on oxidative stress, improve insulin sensitivity in the body, and support blood vessel health in the brain. These are all good things.
Okay, so both are beneficial in those general ways.
Yes, which contributes to their overall benefits.
Yes.
But the really crucial difference seems to be in their direct actions inside the brain itself.
Okay, and this is where it gets really intriguing, right? The glucagon-like peptide-1 receptor agonists, they actually cross the blood-brain barrier.
Exactly. They exude direct central nervous system effects that get into the command center, so to speak.
Whereas metformin, its benefits are more indirect.
Precisely. Metformin's benefits for the brain seem to come mainly from its systemic effects improving metabolism throughout the body, which then helps the brain. But glucagon-like peptide-1 receptor agonists seem to work more directly on the brain tissue.
How so? What do they do directly?
Well, they appear to actively reduce inflammation within the brain. They promote things called neurotrophic factors. Think of them like fertilizer for brain cells, helping them survive and connect. They also seem to improve how the brain uses glucose, which is often a problem in diseases like Alzheimer's.
Okay, so direct support for brain cells and energy use.
And perhaps most importantly, they seem to uniquely target the actual hallmarks of Alzheimer's disease. They appear to help reduce the buildup of those sticky beta-amyloid plaques.
The stuff that gums up the works in Alzheimer's.
Right. And also reduce the tangles of tau protein inside the neurons. These direct actions on the core pathology of Alzheimer's could be a major reason for the differences seen in the study.
That sounds, well, it sounds like a potential paradigm shift, doesn't it? How we think about treating diabetes.
It really does. These findings, they raise some really important considerations about using glucagon-like peptide-1 receptor agonists, potentially, as first-line therapies, not just for sugar control, but for brain health, too.
What did the researchers themselves say about this?
They put it quite strongly. They said, and I'm quoting loosely here, that integrating these drugs as primary therapeutic agents may represent a paradigm shift in preventing the cognitive complications of diabetes.
A paradigm shift? That's strong language in science.
It is. It suggests that future clinical guidelines might start prioritizing drugs that hit both targets: great blood sugar control and significant brain protection.
So for you, the listener, this isn't just academic. It means the conversation around diabetes management might evolve. Your medication could be seen as actively protecting your cognitive future, not just managing current symptoms.
Exactly. Reframes the goal, potentially.
Now, we have to be careful, right? As with any study like this, especially an observational one, there are limitations.
Absolutely crucial to discuss those. This was an observational study. Big asterisk there. It means we can't draw firm conclusions about cause and effect.
Right. It shows an association, a link, but not proof that the drug caused the lower dementia risk. Correlation, not causation.
Couldn't have said it better. That's the key takeaway on limitations.
Yeah.
The researchers were very upfront about this.
What other limitations did they mention?
Well, a few things. While the study period was long, maybe not long enough to capture the full long-term effects on cognition, especially for slow diseases like Alzheimer's.
That makes sense. Dementia develops over decades sometimes.
Right. Also, relying on electronic health records, while powerful for scale, means there could be, inconsistencies. How doctors diagnose dementia might vary, or maybe some conditions like vascular dementia weren't always coded accurately. Underreporting is possible.
Okay, so potential data variability.
And they also pointed out that they excluded people who had switched between drugs or used both. So the results strictly apply to those who started and stayed on one or the other as their first treatment.
So it might not apply to everyone's treatment journey.
Potentially, yeah. And finally, they didn't have direct measures of cognitive performance, like memory tests or specific biological markers from brain scans or spinal fluid. Those would add another layer of confirmation.
Got it. So important caveats to keep in mind.
Definitely. But despite those limitations, the researchers were pretty clear on the next steps. Their message was, further long-term studies are warranted to validate these results.
And what kind of studies are they calling for?
Specifically, the gold standard, randomized controlled trials. That's where you randomly assign patients to receive one drug or the other, or a placebo, and follow them over a long time, using standardized diagnostic methods and maybe even neuroimaging.
Right, the kind of study that can show cause and effect more definitively.
Exactly. That's what's needed to really confirm these findings and potentially change widespread clinical practice.
Okay, so wrapping this up then, what's the big takeaway for you listening right now?
I think the main message is that this study gives us some powerful new insights. Real potential for these glucagon-like peptide-1 receptor agonists to offer a kind of dual benefit.
Managing diabetes effectively and acting as a potential shield for brain health.
Precisely. It's an encouragement, really, to think broader about diabetes management. It's not just about the numbers on a glucose meter today, but about overall well-being, including cognitive function, for the long haul.
Optimizing health across the board.
Yeah, and maybe helping patients and doctors make more informed choices, considering the full spectrum of benefits a medication might offer.
And that kind of leads us to a final thought, something for you to mull over. If medications, like these ones, can have such varied and profound effects on different parts of our health, blood sugar, heart health, maybe brain health, even mortality, how might that change the conversations you have with your doctor about your own treatment plan, especially as we learn more about how complex diseases like diabetes and dementia are interconnected? How much more personalized and holistic could or should our healthcare become?
That's a great question to reflect on. The future of personalized medicine in action, perhaps.
Something to think about. Thank you for diving deep with us today.
Thanks for tuning in to the Health Headliner podcast by To Digital. Like and subscribe for more health news and breakthroughs. Stay healthy and informed. See you next time.